All right, so we are going to do some modeling with real world data pertaining to your sine and cosine graphs today. So in the box at the top, I listed everything that you are going to have to use. Another phrase that you're going to notice up there is equilibrium. If you see that in your homework questions, that is referring to a midline value. So that's the C value all the way at the back of the equation. So number one says the tide in a every 11.6 hours. Okay, so stop. This refers to which trig vocabulary word? Amplitude, period, frequency. This is the period. This is the amount of time it takes to make one complete cycle and repeat again. The next, it says the tide ranges from 3.9 to 3.3. So that is going to be my maximum and minimum. So suppose low tide is at 2 = 0. All right, so we want to write a sine function that will model the height of the tide. So you need everything here. So we need amplitude, we need frequency, and you're not going to do anything with a phase shift unless it's specified. This was not specified, so you don't need it. So first things first here, let's go and find your amplitude. So there is a formula for amplitude. I think I put it in the box, didn't I? Or did I not? I did not put that in the box. So here, if you'd like to add it for it. Amplitude is equal to max minus min divided by 2. You can add that one if you'd like. Go down here too, where it says midline. Throw this in here. That is your maximum plus your minimum divided by 2. That's pretty much all of them now. So when I go to do this amplitude, I am going to do my max minus min divided by 2. Again, nice and formula driven here. So A is equal to, so I am going to go 3.9 minus 3.3 divided by 2, which is 0.6 divided by 2, which is equal to 0.3. And again, these are real world examples of how you could use your sine and cosine curve to model a scenario. So high tide, low tide, something that is periodic in nature. Next value, I'm going to find the midline next because it's just easiest. So my midline value is equal to my max plus my min divided by 2. So I am going to do here, and again, a lot of times it's referred to as C if you don't have a phase shift, but if you have a phase shift, it's referred to as a D. So just so you know and don't get confused by that, I'll just leave it as a D. So my max is 3.9, my min was 3.3, and then divide that by 2, you would have that 3.6. Thank you. So 3.6. Again, if there's no indication of a phase shift, which there is not, you can assume that that's nothing. And then we need one more item here, and that is our frequency. So last but not least, my frequency value. So what I'm going to make use of is that period is equal to 2 pi divided by frequency. And you have one of those items listed somewhere, the period. So I'm going to go 11.6 is equal to 2 pi divided by b. And b is, again, just a variable, so it's your frequency. I'm going to cross multiply, and I get 11.6b is equal to 2 pi. And then divide by 11.6, and this doesn't simplify. I'm going to just leave it like that. So b is equal to 2 pi over 11.6. Now you're going to take those 3 items and you're going to write a sine function. And letter B is just calculator work, so if you need to use that space, please feel free to. So here's my answer for part A. So I'm going to go y is equal to, and you're going to notice they use t instead of x, so I'm going to do the same. So we have 0.37 sine. And then I'm going to go parenthesis for my frequency, which was 2 pi divided by 11.6 times t plus my midline value, which was 3.6. Just like that. How's that so far? Pretty good. You won't find word problems to really be that bad. Just pull out the vocabulary and do the formula. Now letter B, you are going to calculate the height at 6.2 hours. So that's going to get replaced for t, and there's one other trick to this. This formula right here is in what form? Degrees, radians. Radians. So your calculator must also be in radians. So let me write this first, and then we're going to type it. And you absolutely want to make use of parentheses for that product and that alpha y equals t as well. All right, and then times, I'm going to sub in 6.2 and plus 3.6. All right. Let me see if I can remember all of that. So we're going to type that in. Again, enabling your calculator to radian mode. So radian mode. Then I'm going to go back here and I want, so 0.3 sine, and I'm going to go alpha y equals enter just to make that a little bit easier. And I'm going to go 2 pi divided by 11.6. And then I am going to multiply that by 6.2. And I'm going to add my midline, which was 3.6. That is not what I want to get here. So I need to add another parenthesis around that interior portion there. What did you guys get? Yeah, that's correct. I knew I needed another parenthesis here because we got to keep this product all together. So let's see if we can do this. Yep, and then go all the way over here and hit second insert so you don't have to retype it. Oh, that's not what I want. Not gonna work for me. Nope, I gotta get rid of that there. Bear with me. I want to put it after the sign. All right, right there. Second insert parenthesis. Oh goodness. I apologize. This calculator is sometimes real difficult to work. So I'll write it on the board how you're going to type it. Again, just please make use of the parentheses. I'm giving up on that calculator. It just kind of spazzes out sometimes. All right, 3.5. 3.5. Again, let me just make sure, you know, you've got parentheses around this whole entire product. Okay. So take your time with that calculation. Here's another real life example. So this is blood pressure. So blood pressure is going to oscillate between 160 and 60. So what do those refer to? What am I going to label them as? 160 is mine. Yep, max and min. Max and min. And your heart is going to beat once every second. So what's this refer to? Period. Yep. Right, another sine function that models blood pressure. So again, you're just going to make use of these formulas once more. So I am going to do my amplitude is equal to my max minus min divided by 2. So therefore, my amplitude is equal to 50. I'm going to immediately go and find my midline value next. Again, this has no phase shift, but I'll call it D regardless. So we're going to go 160 plus 60, and then divided by 2, which is 220 divided by 2, which is, did everybody get 110? And next I need to find my frequency. So to find frequency, that's a B, I'm going to make use of the formula that period is equal to 2 pi over frequency. Again, as long as you know one of those items, you can make use of that formula. So I knew the period was 1 second, and then cross multiply solve if you really need to. So B is equal to 2 pi. All right, so now you're just going to throw this in here and generate your equation, and you do not need to go any further with it. So I'm going to do a sine curve. So we have y is equal to amplitude, and then sine, and then parentheses, and then I would go 2 pi multiplied by t, and my midline value was 110. Okay. How do we feel building the equation? Pretty good? Okay, now we're going to draw some. Just sketches though. So you have times that can be modeled by a static cosine curve. So if you remember from yesterday, a cosine curve starts high and finishes up here. So this is your basic cosine curve. That was the second one that we did yesterday. T represents the hours since high tide, and D represents the depth of the water in the bay. The maximum depth is 36. Again, you want to grab that information. Minimum depth is equal to 22. High tide occurs every 12 hours. So what does this refer to once more? Period. And then it's just going to repeat again. So it says to sketch a graph of this scenario for 2 full periods. 2 full periods would be how many hours? 24 hours. Good. So that is 2 full periods. So I'm going to come over here, make a coordinate axis and a sketch. It does not have to be anything on graph paper. Okay, so here's what I need to know. I need to do it for 2 full periods. Thus, it's going to conclude at 24 hours. Halfway mark is 12. I find it helpful to sometimes grab those values in between. And now you're going to do your max and min. So minimum is like 22. And maximum up here at 36. Bless you. And you're going to sketch. Okay. So we are going to start up at our maximum of 36. We're also going to end at 36. That's one complete cycle. So halfway in between, I'm at 22. There's one coast curve. And then all I do is replicate it on the other side. Again, they are periodic in nature. And there you go. What do you think? Pretty easy? Just a sketch. Determine the values of A, B, C in this model. So we already did that above, so same formula. So amplitude is equal to max minus min divided by 2. So 36 minus 22 divided by 2. So I have amplitude is equal to. Yep. Next, I need to find my, and again, C is referring to your midline value because you don't have a phase shift here. Okay. Don't mean to confuse you by that. So my C value in this case, which is again your midline. So I'll kind of distinguish that for you. So C is going to be equal to 36 plus 22 over 2, which is 58 over 2, which is 29. And then we need the frequency value, which is derived from the period formula. So I'm going to do period is equal to 2 pi over frequency. And we know one of these, period. So 12 hours is equivalent to 2 pi over b, cross multiply and solve. So 12b is equal to 2 pi, divide, simplify. All right, so my frequency value is pi over 6. All right, and once more, you're just going to place all those in your equation, but this time it is the cosine curve, and it starts with the letter D. I'm going to do D is equal to 7 cos of pi over 6 times T plus 29. How do we feel on the word problem so far? Pretty good? Awesome. So flip on over. There's one little twist to this one. I'm sure you have all been on a Ferris wheel at some point in your life, right? Okay, where do you get on the Ferris wheel? At the bottom. Yep. So if you skim this question, you are given that you need to write a cosine curve. And a cosine curve looks like this. Or a cosine curve looks like this, takes a big deep valley and comes up. But obviously it would make no sense in the context of this question that you're going to get onto a Ferris wheel up in the air. So what I have to do with this cosine curve is I've got to flip it. I got to start at the bottom, work my way to the top, and then back down. How do I go about doing that? What do I need to make my curve do? Yep, negative in the front. I need to make it reflect over the x-axis. You're going to do that by placing a negative in the front. We just have to remember that in a minute. Information we have here. Ferris wheel is constructed such that a person gets on its lowest point 5 feet above the ground. Minimum equals 5. Highest point is 130. Keep reading. What do we have next? Amount of time it takes to complete one full rotation is 8 minutes. That is my period. And then it says to sketch graph for one full cycle and determine values of A, B, and C, where again, C is referring to your midline. So another little sketch here. Again, just a sketch, nothing that you need to use your graph paper for. It really doesn't apply here. So I have a minimum value of 5, a maximum value equal to 130, and I'm going to make one full cycle, concluding at 8 minutes. Halfway is 4. So here's 0. So this is time in minutes. Really should be labeling these, I apologize. And then next over here is going to be your height in feet. Okay, you're going to sketch your curve. Again, remembering when you get on a Ferris wheel, you get on at the ground level, but not obviously right at the ground or the cart would scrape against it. So it's a little bit elevated. I'm going to make one full cycle after 8 minutes. And I'm going to reach my maximum value after 4 minutes. So there we go. So here are all your values again. Going through them quick because again, we've already done these formulas. Amplitude is equal to max minus min divided by 2. And if someone could grab these are decimals this time. There, you got it. Thank you. Next, I'm going to do that C value. So 130 plus 5 divided by 2 is 60, is it 67.5? Thank you. And lastly, you're going to do period is equal to 2 pi over frequency. And I'm looking for 8. So we have 8 times B. If you cross multiply equal to 2 pi. You're going to divide by 8, and again, it would be helpful to reduce that to pi over 4. Now, when you go to pull all that information into your final equation, don't forget that we need to place the negative in the front. So I have y equal to negative 62.5 cos of pi over 4 times t plus 67.5. And again, the negative is not referring to amplitude, it's referring to that reflection. Okay, how's that one? Pretty good? All right, one last question. So if the equilibrium, and again, above that, can you write midline, because that's all that's referring to, is y equals 0, which makes sense. There's nothing added on to the end of this equation. Then y equals -4 cos of pi over 6t models a buoy bobbing up and down in the water. Find the period and the location at t equals 10. So that's it, 2 quick little formulas. So I'm going to go period is equal to 2 pi over frequency. Just making you write them and get comfortable with those again. So period is equal to, and I'm going to go here 2 pi divided by, and my frequency is that entire coefficient, pi over 6. So we're going to do keep, change, flip. Got 2 pi over 1 multiplied by 6 over pi, which just gives me 12. All right, and then lastly, we need to calculate at t equals 10. So this is calculator work again that you are going to type in. So I am going to go y is equal to -4 cos of pi over 6 times 10. All right, and then go ahead and type that in. What do we get from that? I'm not using the calculator on the screen. I'm just kind of, I get frustrated with that one. So we're going to go -4 cos, and then you're going to go alpha y equals, or you can make use of double parentheses. And you're going to go pi over 6 and multiplied by 10. I guess I'll put that up here just in case people need it. I will try. Let me go slow. So -4 cos, and we're going to go pi over 6 and times 10. So you guys get -2. Yep, so solution is just going to be -2. Okay, so that is going to be your location. Back over here, and that is your final answer to that one. This would be y equal to -2. So on those 5 questions, any problems or we're good? Again, make sure you refer to all those formulas in the top box. So for homework, and you're welcome to get started on those right now, you've got textbook problems. I believe I need to take a picture of that page, so I'll do that for you in a minute. Yep, so for homework, you have just portions of questions. So please pay attention to this because I don't need you to do every single part to some of these. You are doing question 7, just A and B, all of number 8, number 9, just A through D, and then 10 and 11. And if it refers to any sort of graph or the need to sketch one, you don't need to use your graph paper for those word problems. You can just make a sketch right in your notebook. Okay.